Okay, I'm building the Forj programming language, or Forj. So I want it to be a practical language that you can actually use for productive things. I think it actually has some features that are powerful enough to become a mainstream language, or at least be adopted by mainstream languages at some point. So, what are some restrictions? So, in general, big applications need stronger type systems because the type systems constrain them and prevent bugs. But also, small apps, perhaps more controversially, prefer weaker type systems because you want to be able to build something fast. So the solution is to be able to adjust the type system strength dynamically, right? Like increase or decrease the strength whenever you need it. So one idea for this is to use metaprogramming for types, where you can kind of like program with types. And there are some languages that, like dependently typed languages, that use a bunch of math to kind of create these really powerful type systems, but they're also very brittle in a way. So actually, this might be better phrased as compile time execution. So you may have heard this phrase that types are a compile time construct. So they really like only exist at compile time. So it makes perfect sense to use compile time code for type checking. Well, to accomplish that, first of all, code must be easily manipulated by other code. And there's this other phrase, code as data. Some languages like Lisp have this concept. But actually, in a way, this language takes it further, and it's kind of code is data. It's bidirectional. Code is data, data is code. And so you can kind of execute data as code. So to do this, we need a consistent syntax. And I took this very seriously. There are pretty much no exceptions for syntax. And so on that note, we have a unified call operator that works the same way everywhere. And it's stack based. That gets into the data as code or data is code aspect. So here's regular code in a language where you add 8 and 2. So because Forj is stack based, it uses reverse Polish notation, which looks like this, where the operator comes after the data. It's a little unintuitive at first, but it cuts down on parentheses and it allows you to have this consistent function application syntax, instead of like some functions going in between their operators and some going on the left and some going on the right. We just only use this and there's no exception. So back to that unified call operator, you actually have to manually call every function. So even addition, and that's done with a dot, a period. So the previous, just if you just put 8 2 plus, that will not add the numbers together. You need to apply the operation. So here's another example. So we have a string and we print it out. And so the other thing is that these data points are called atoms, and you can create a new atom by calling the new atom function, and then you can open those up and put stuff in them. So here we are opening up the atom and we're putting 8 2 and then adding it together and then closing the atom. So here's another example. So in the same way that this is putting stuff inside the atom, actually now the atom becomes a function that contains the number 10 and just returns 10 basically. So here's another function example. This just takes that print example from earlier and turns it into a function rather than something that's run at compile time. But notice this, these two dots here. So this is actually a special operator that is different from those other dots, and it basically just escapes them. So when you run this code, it will output this object. So note that we're putting this data into the atom. So we put that string in there, then we put the print function, and then we put a dot. And since it's that double dot, it's escaped, and you just end up with a single dot. And if you were to run this atom, it would print out hello Forj. So the one exception for syntactic sugar is this, which is this is a unique way to declare a string that restricts it to be only one word. So you just put a colon in front of anything and it makes it into a string. And the exclamation point is also included in this. So this is how variables are declared. All you have to do is just put a string in front of any object, and if you reference that again, it will go and find it and use that. So you can actually declare variables with any string, even spaces, though you have to call them in a more obtuse way. But you can use any amount of symbols or anything. There are very few reserved symbols. So again, we used say hi, so that brought this out, which is just the copy of that function that it's named as. And then if we use that dot on there, then we'll get the printout hello Forj. So onto type checking. So I talked a lot about type checking in the beginning. Type checking is really important to me. I think it's valuable. So here's an example of how you might do that. We can make some type assertions like this. So in this case, int is a function that returns a boolean of whether its argument is an integer or not. And then we're applying that over each object in this atom. And so this would be the output. We'd get 4 trues because we had 4 integers. And then we can basically reduce that down, boil it down with an AND operator, and then we would get true. So basically this is just asserting that every value in that atom is an integer. And so just an example for what that would look like if we did not have all integers, we would get false there. And then when we reduce it down, we would get false. So hopefully this gives you an idea of how you might make some higher level assertions about the shape of different functions. Of course, you could assert basically any property about a function because it's literally just data. So in many ways, it's actually more powerful than dependently typed languages, those math languages that I talked about earlier. Even though Forj is less rigorous, you can sort of surgically assert much more deep properties about like how the code is actually structured and stuff. And this link will take you to the Discord server where I have a bot set up. You can play around with the language without downloading anything. I would also love ideas or suggestions or contributions as well, would be amazing.